today's subject is the Conext SW inverter charger, which you see here on the screen. It's a smaller version of a true sine wave off-grid / battery backup type of inverter with a lot of new features. The way the presentation is set up today, the new features I'll save to the end because there has been some major changes. So right now I'm showing that as a new feature thing. In the future I'll be changing that to be just inclusive. But let's see if I can get my screen to move forward. So the way we're going to cover it, we're going to talk about first the inverter itself, specs, features, things like that, things that make it very valuable in the market. Then we're going to talk about the applications that are relevant to this inverter. One thing I might add here is under the inverter section, I've got just a brief slide on just when to choose the XW Plus, the larger sibling, if you will, and when to choose the CSW, the smaller sibling. That's one of the most frequent questions I've got when talking about this inverter. So we'll be talking about that. Applications. This is part of the back to when to choose what, but we'll talk about the applications that are relevant for this inverter. And the last section I'm going to say for upgrades. These are all features that are new in the revision 3 and up firmware, which is available on the web now for your download and upgrade. There are a lot of new features. The most publicized one, of course, is a new 48-volt unit, which is much anticipated. But I think some of the other features are maybe even equally as important. So we'll talk about all that. And again, and I'm going to say it again, and I'll say it, if you don't start asking questions, I'll remind you to please ask me questions. So, the Conext SW inverter charger. Again, it is an inverter charger, which is something we learned about in the Inverter 101 section, right? It can invert from battery, and it can charge batteries with an AC source. Just to make sure that's clear, the difference between a charge controller and a charger is a charger, like the CSW, Conext SW inverter, uses an AC source, be that the grid or a generator. A charge controller uses a DC source like a solar array. So 24 and now 48 volt based inverter charger. And this is really important. I just came back, actually flew in last night from a Midwest Renewable Energy Fair where I spoke about some economics of off-grid systems. And one of the things that I talked about was the advantages of 48 volt systems over, say, 24 or even more so over 12. For instance, when it comes to your charge controller sizing, you can put twice as much array in a 48 volt system on a charge controller as you can on a 24. So really, this move to add a 48 volt unit to our lineup in this size range means that you could potentially save half the cost on your charge controller. So that's a big one. 48 volt is better. There's not really many disadvantages to lower voltages. People run less and less straight DC loads than they used to. Pretty much everybody runs AC loads. So we've got a 2.5 kW and 4 kW unit available. The 48 volt is only available as a 4 kW, which I think makes sense. So in 24, it's either 2.5 kW or 4 kW. For the US version, the UL version, if you will, it's 120, 240 split phase. So you can feed your standard split phase load centers. Huge advantage, I believe. For the IEC versions, I didn't finish that sentence. For the IEC versions, or what I call rest of world, the 50 hertz model is 230 50 hertz. The UL version, and I'll show you some graphics on this about how important this is, but it has a built-in 120 to 120, 240 auto former. Another big cost savings feature. A lot of smaller systems in off-grid applications, though they want to feed a 240 volt load center in the cabin or home, don't necessarily need a larger 240 volt generator. They can actually run a 120 volt generator in. I'll show you that in some graphics if you don't understand that. Switchable 50 or 60. And this is for both units, the UL and the IEC version, which is really nice because it opens up a lot of the world for us. For instance, Jamaica uses split phase power like they do in North America. But just to be different, they use 50 hertz. So you can take the CSW UL version or the CSW, Conext SW for North America, reprogram it for 50 hertz operation, and use it in Jamaica. Now, for places like Korea, where they use the 230 volt power, you know, similar to Europe, but they use it at 60 hertz, like we do here in North America, you can program the IEC version for 60 hertz output. So really, this pretty much leaves us open for the entire world as we know it. 2 units can be operated in parallel to make an 8 kW system. So though we have, it's a 4 kW by itself, it is stackable, parallel stackable as I would call that, for double the wattage output. So we can go 120, 240 at 8 kW or 8 kW at 230, 50, switchable of course. Advanced AC power, interactive solar priority, and self-consumption modes. I'm going to talk more about that later, but basically the inverter has some really nice features. Though we think of this inverter potentially as a smaller and mostly off-grid unit, it's got some really good on-grid features for self-consumption type models and grid support, which I'll talk more about. Generator load support, which is another function of this AC input support, but it can basically give you the ability to utilize a smaller generator, which when you're only using a generator for backup can be a huge advantage. Available AC and DC integrated switchgear. I'll show you pictures of that. And again, I'm going to reiterate it because it's new, 48 volt, 4 kW version available soon. And when I say soon, my understanding is middle of July, but you know, the things are always a little bit fluid when it comes to product availability. With all manufacturers, as we want to make sure we get things right. So, one of the bigger questions that has been asked me of the SW versus the XW is when should I use which? On the surface, it appears as though we have competing products with ourselves, but in reality, we don't. And there's a couple things that there's applications where the lower cost Conext SW is the choice, inverter choice, but there's also times when you don't want to use it and you will want to use the XW Plus. And the top 3 items are differences, and the bottom 4 are things that I really like to point out here that are similar as far as features, because they come up quite a bit. So the number of AC inputs, this is a very important one. The XW Plus has 2 AC inputs, grid and generator input, separate, which means that you don't need an external transfer switch in an on-grid battery backup with generator application. Now, the Conext SW, the inverter we're speaking of today, is grid or gen. So if it's a pure off-grid system where you don't need 2 inputs, it's a cost savings feature. If you're on-grid and you either already have a transfer switch or you don't plan on using a generator, the Conext SW is very valid as well. So again, just to kind of reiterate that, if you're doing an on-grid battery backup system with generator, you may want to consider the XW, the bigger sibling of the SW. The DC grid cell feature, this is another one. The XW Plus does sell back DC. Note, oh, I didn't say no here. I can change that on the fly for you all. No. See? Get my presentation done by the end. That's my goal in life. So the CSW, though it cannot sell excess energy from the DC bus, it can function in an AC coupled system. So if you're doing an AC coupled battery backup system with cell back, the SW, yes, it will work. I'm going to get into more detail about what I mean by yes, it will work versus there's different applications for AC coupling. But if you were looking at doing a system using charge controllers, which we call AC coupling, and want to sell back excess energy to the grid in a net metered fashion, then you would want to consider the XW Plus. Now, another time you'd want to consider the XW Plus is for larger system size. With the SW, we can stack 2 inverters. That's the limit. Again, intended for smaller systems. We can go up to 8 kW, and that's load carrying capacity. Now, with the XW Plus, we have the ability to stack 12 inverters, which results in, almost 82 kW for the North American units and 102 kW for the rest of the world. So for village electrification or for a very, very large, beautiful, rich home, we may want to consider the XW Plus. Smaller systems, what I would call an appropriate sized backup system or an appropriate sized off-grid system, the SW is 8 kW is actually quite a bit of power in an off-grid system, to be honest. So for the smaller residential systems, the SW, less money, plenty of power, and lots of features, which I'm pointing out here below. Some of the features that aren't differentiators, and I want to say this because I want to really say how good of a system the SW really is here. The grid support function, which I'm going to talk more about, but it's the ability to contribute the DC energy onto the AC bus to minimize your grid consumption and maximize your array consumption. The SW does it. Now, the only thing it won't do, again, item number 2, is to sell back. So it can't go backwards, but it can do what I would call grid support. I'll have some graphics if you don't understand that, and we'll understand it more about the end of this. Fully ZAN bus compatible. This one is huge. If you're looking, one of the advantages of the Schneider gear is that we have many components, which I'm going to point out here. I'll have some graphics of those, that we can tie into our network that all communicate together. Charge controllers, automatic gen start, battery monitors, these sorts of things, web access, monitoring. Both inverters are fully ZAN bus capable. They just daisy chain in the ZAN bus, either or. So that is not a limiting factor if you choose the SW. AC coupling capable, yes, on both accounts. I'll talk more about that. What that means to be AC coupling capable. And, though, don't think that you can just hook up random bulk cells. Both units do feature lithium-ion support, which I'm going to talk about in detail because it's important to know what you can and can't do from a lithium-ion standpoint as they become more and more prevalent in the industry. So we'll talk about that. But that's the key differences. So, balance of system. From a module standpoint, module manufacturers say that the balance of system is everything except the solar panels. Inverter guys like myself, what we consider balance of system is DC and AC switchgear for the inverter. So what you see on the left side of the inverter, actually on the right there is the inverter, the Conext SW inverter. On the left side, what we see is the optional integrated DC switchgear. Ties in very nicely, looks good. This is used in both the IEC, rest of world, and the North American market. Basically includes the basic wiring needed for an inverter on the DC side for either or units, because it's the same, whether it be 50 hertz or 60 hertz units. You have the ability to mount the system control panel, which is part of our ZAN bus network. You have the ability to mount that in the front cover, which makes for a very tidy installation. I would believe that most homeowners actually take that into the home where they can see it more easily. Oh, I sense a question there. Came off mute. Somebody over there that just came off mute. Okay, there we go. Okay, so if you need to come off of mute to ask a question, please feel free, but it gets very noisy, especially if a few of them out there. So, where do we leave off? Oh, the system control panel, which actually, and I'm going to talk more about this, is not required. There's two different ways, really, to program the inverter. One with the system control panel, for those of you who like to push buttons on a local display. And we also have something called the COM box that we can use to actually program it via PC, which in my opinion is much easier, and it also gives some other features. So basically, at this point, I would call the system control panel optional, where I never did in the past. What you see on the bottom is the optional AC switchgear for the North American market. It's 12240 with the integrated bypass assembly, which is not to be confused with the internal transfer relay. If you have any questions on that, please ask, but I'll just state that. And on the right side, you're going to see the optional AC switchgear for the rest of world market. Note that in almost all applications, North American AC switchgear is larger, more complex, more costly, and more cumbersome than the rest of the world, as we have much higher requirements. In my opinion, sometimes more than necessary. So the AC switchgear for the rest of the world, which you see on the right side, is much simpler, and I'm sure lower priced and very much simpler. But for the North American market, we have the switchgear as well. So here what we have is a list of, or a graphic and a list of some compatible products. So we see up the COM box up on the upper left-hand side. That's what I was speaking about earlier as an option to using the third item down there, which is a system control panel. But in almost all instances, I would recommend that you have one or the other. You can do the programming, and programming is necessary. Just because it's not included in the inverter doesn't mean it's not really required, but at least for programming as a tool for the installer. I personally prefer the COM box. It's a little bit less money, and it gives you some additional data logging. It gives you the ability to go out on the web and post your production and do monitoring on our Conext Insight server, which is a free service. It's much easier to update firmware within the rest of the devices in the network. Really a great product. The COM box, in my opinion, is a high one on the list as an additional sale with the Conext SW inverter, as is the item to the right of it, the Conext battery monitor. In my opinion, any battery-based system should have a battery monitor, and that's ours included. But note that our competitors that have external battery monitors don't actually have them communicate on the network and help make decisions as far as things like absorb time, generator runtime, and that sort of thing. In our system, because we're all tied together on the SAN bus network, that device actually communicates with the inverters, with the charge controllers, and all information is shared. All temp sense information on battery temperature is shared, and really great product. So in my opinion, the two almost required items to sell with a CSW system are the two top, and that is the battery monitor and the COM box, giving you the ability to program and the ability to monitor batteries. There we have, I talked about the AC distribution panel, the 230-volt rest of world unit. What we see down on the left side, we see the DC distribution panel, which I showed you a better picture of earlier. The system control panel, which can give you the ability to program all the devices as well. Using menus, which a lot of people are more comfortable with. Personally, I like the PC interface of the COM box, but you can use either or both. The Conext MPPT 6150, which is our 60 amp, 150 volt maximum controller, works really well with the inverter. Again, tied together and communicating over the SAN bus network. The on-off remote switch, for a very simple installation, you can use this just to turn the inverter off and on if that's required. Personally, I would, if you were installing a customer system where you didn't want to leave behind a programming interface, I would have either a system control panel or a COM box on your truck to do the setup prior to just leaving behind the SW on-off remote switch, but that's my opinion. Down the right side of the AC distribution panel for the US, we spoke about that, 12240 with the bypass. The next item down is the automatic gen start. If you're doing automatic gen start with a two or three wire start, that device ties into the SAN bus network as well. If you're doing two wire start and you have a charge controller, there is a set of contacts that you can do and not use the automatic gen start. If you're doing 3-wire gen start with the SW, you will be required to have the automatic gen start module. 3-wire start's a bit more complicated. But again, 2-wire start, if you have a charge controller in the system as well, you don't need to have the AGS module, though I would recommend the battery monitor in particular at this point, because then you can start the generator based on state of charge as opposed to voltage, which is much more accurate and fuel efficient. The next item down is the MPPT 8600 charge controller, which the way our vernacular works, that's an 80 amp, 600 volt controller. So we can bring in basically the same voltage array as commonly used in grid tie inverters for residential, which can do a really big savings on wire sizing, in particular on longer runs. Anything over, boy, I'm working on some more data on that by right now, but I know at 300 feet, it's a no-brainer. But even if you're maybe 100 feet from the array, the 600 volt controller, though a little bit more money, can actually save you in copper. And then the stacking kit, that's for taking 2 inverters, the SWs, and stacking them together for parallel. That's required when doing that stacking. So that's the items that we sell along with it. So we've got the inverter down, and now we're going to talk about some applications and where it's relevant. I apologize for that. There was cars honking outside my window. So for applications, which applications are relevant? What we show here now is a residential backup system. And remember, actually, I was going to change this screen this morning. This is an incorrect screen, and I'll point out why here. The SW actually only has one input. So we see the grid coming into that main panel on the left-hand side, coming into AC1. This really is a graphic for a XW Plus. I apologize for that. The generator AC2 does not exist on the SW, so you would do either or. That AC input would either be from a grid or from a generator via a transfer switch. The one slide I forgot to change. What you also see here is all of our items on the SAN bus. So in this system, we're showing an AGS, an SCP, that's the control panel, the comm box, the monitor, battery monitor, all tied together. And if we were to ignore this generator here for a moment, pretend that that generator is not there, what we would have would be a residential backup system. And in a residential backup system, rarely do we see the inverter system feed the entire home. And there's many reasons for that, but mostly cost. To feed, in particular in North America, to back up an entire home requires a very large stack of inverters. A residential 200 amp main panel is capable of 48,000 watts and over a 24-hour period of time delivering 1.152 megawatt hours of energy. So the proper way to do a residential backup system is to have an electrician take out the critical circuits that you want to back up, put into an AC sub-panel that we see there on the right side. That way, when grid is available, it comes into the AC input, feeding the loads on the main panel. Those are your larger loads. There's your electric water, there's your electric range, there's your hot tub, there's your copper smelter, there's your pottery kiln. All the larger loads are not going to be backed up by the system. On the output, there's where you're going to have your refrigerator. There's where you're going to have one of your TVs. There's where you're going to have LED lighting and the things that you want to have operating when the power goes out. Much better approach to it. Many people do an external transfer switch to get by it. If you have any questions on this, the proper way to do that, I won't go into in painful detail here, but my email address will be posted at the end of the presentation. So, as all battery-based inverters, we see the battery bank down below. That's required. It's not optional. Though the SW does have dead battery charging. So that means if you do inadvertently, please don't do this, kill your batteries completely, the SW will actually charge it again. Most residential inverters don't do that. Now, again, if the AC were coming into the AC transfer switch, which is a 30 amp 240 switch passing through to the loads, in the event of a power outage, that internal transfer switch would open up and feed the loads on the sub panel. So this would be a pure backup system. Now, if I were to take the AC main panel out of this picture and have only the generator come in, this would be your typical off-grid situation. The only thing that would really change, other than we don't have a grid and we have a generator coming into the AC, is what we see on the AC sub panel there. I wouldn't call it a sub panel at that point. I would call it the main panel. That's an off-grid situation, because normally off-grid homes require less energy because, well, they're doing it themselves. They're not connected to a dam or a nuclear power plant or a coal-fired power plant. So in an off-grid system, the generator comes in, can be auto-started via that Conext AGS in the top. When the batteries go down to a programmed value, state of charge, that the Conext battery monitor is monitoring, the AGS can trigger the generator to start, which will then pass through the inverter onto the AC sub panel. One of the things I alluded to, but I'm going to have some better graphics on here coming up, is that generator, though it says down there 120, 240, or 230, in a North American application, could actually be a 120 only generator. So I'll get to that in more detail. Real nice feature, saves you the cost of buying that additional $500 or $600 auto transformer. So in a self-consumption application, and this is becoming more prevalent as we're getting more and more jurisdictions that are saying no to net metered grid tie. Hawaii is a good example. There are others. I know I just came back from Wisconsin, and they were basically changing their net metering agreements so that instead of rolling over excess energy stored in the grid annually, they're doing it per billing cycle, which means that people are more apt to want to use that excess power and do something that I call, or we all call, self-consumption. And what self-consumption is the terminology that I've come up with as best I can, I'm open-minded to better, is the ability to use as close to 100% of your solar production over the course of a 24-hour day. So you've got your 4 or 5 hours a day to make that solar power, and you've got 24 hours to use it. Now, in a net metered application, that's very simple. We just send it back into the grid. That AC input would be bidirectional. But in a self-consumption application, really the key is that is not bidirectional, and the grid does not allow us to sell to it. And so in a residential self-consumption system, what we're doing is a number of things. We're basically limiting what we're using on the grid and utilizing the energy stored in batteries. And we have a number of really nice ways to do that with the CSW inverter. So again, for a one-way ticket, not selling back that DC. So the one thing that you keep in mind here is if the batteries are full and the loads are low and the solar is big, we have nowhere else for that energy to go. So that's where the self-consumption, utilizing the batteries, leaving room in the batteries, if you will, for solar production during the day becomes important. Lots of ways to do that. I won't go into painful detail because I don't have time for it today in an hour, but just be aware that the CSW is a great inverter for that. And that is for AC, that is for US, North American 120, 240, or 230, 60. So there's your self-consumption. So you can do off-grid AC and DC coupled. And here I'm going to talk a little bit about DC coupling and or AC coupling and what that is. So in a nutshell, AC coupling means tying together things on an AC bus. DC coupling means tying together things on a DC bus. But in our solar electric world and inverters, what we specifically mean by that is that we're talking about how the solar array is brought into the system. So if you look at the bottom there, you're going to see PV modules going through an MPPT 60 150 controller. That's a charge controller, remember, because it is a DC to DC device. Goes to the batteries and then into the system. That's what we call DC coupling. On the right-hand side, you see the sub-panel. And really, in a nutshell, what AC coupling is now that we've created a grid on that sub-panel, we can now grid tie into it. And the inverter that we see up above there, the Conext RL, is an inverter that's actually only available in the 50 hertz world. It's a rest of world unit, but you can use others. Other grid tie inverter manufacturers can be used, and I'll talk a little bit about which ones can and which ones can't. And actually, any excess energy from that array and that grid tie inverter that is not used by those sub-panel loads, or in the case of an off-grid system, it would be the main panel loads, can go back into the CSW inverter and be used to charge batteries. One of the caveats that we have in AC coupling, and this is every inverter manufacturer out there. I've worked for most, if not all, of my U.S. competitors anyway, and we all suffer the same problem, and that is that when we are charging with an AC coupled source into an inverter output, in other words, we're AC coupling, though we can charge the batteries, the inverter cannot regulate the batteries because basically a grid tie inverter will deliver all current available to it. So in other words, if I've got a 5 kW grid tie inverter there, 2 kW of loads, the excess can be used to charge the batteries, that excess 3 kW. But if the batteries are full, there's nowhere else for it to go. So it will continue to charge the batteries to a very high voltage. Not good. So there are 3 ways that inverter people and installers have come around to limiting that and protecting the batteries. And the first is to use some sort of a voltage-controlled relay to basically simply disconnect the grid tie inverter whenever the batteries get full. A bit kludgy, puts the battery-based inverter into an error mode, thinking that the grid has failed, but it does protect the batteries. But it takes external hardware to do this. Some sort of a voltage-controlled relay that's usually feeding a larger relay, an AC relay, to disconnect the inverter. But it works. The second, which is one that is either the best or the worst option, depending on what you have for potential loads, it's something I call diversion load. And what diversion load is if, for instance, I have 5,000 watts of solar potential, I want to have a load on my battery that can run at any time or at any temperature based on state of charge. So, but you want that load to be larger in case of edge of cloud effect, snow on the ground, and higher output than normal. So, for instance, if I had a 5,000 watt grid tie inverter, I would want to size my load for 125% or 6,000 watts. In other words, if the solar was producing well, the loads were low, the batteries were full, we would have some sort of a voltage-controlled relay to dump the excess energy. So if you need to use it or have a good place to put it, defrost your driveway, I've seen that done, fine. It can be a good way to do things and utilize that excess energy. But if you don't have a good place for it, running a 6,000 watt electric heater in your home can be a bit unnerving because it has to happen typically when the sun is up. So that's not the best way. The third and the best way is what we mean when we say that the CSW is AC coupling capable. And what it is that while this only happens, by the way, because if we were tied to the grid, if that generator out there wasn't a generator, it was the grid. If there was excess energy, the batteries were full, and we were tied to the grid, that excess energy could be net metered back to the grid. It could be sold back. So the problem only arises when the grid is down, batteries are full, and the loads are low, and the production's up. So what the CSW does, like the larger sibling, the XW Plus, is it can change its frequency. Now that change in frequency can be used in 2 manners. The simplest manner is an inverter can see that shift in frequency as a signal that the grid is bad. We all know about UL 1741, IEEE 1547 grid tie requirements in North America, and the rest of the world has their own, I don't know the numbers, but there are anti-islanding protection requirements. So if an inverter goes into this mode where it changes the frequency, it can knock that inverter offline, therefore protecting the batteries. That's the simplest. Now, I know best to the North American market, so this works with inverters like Enphase. So if a customer already has an Enphase system on the roof, doesn't want to rewire the array, they can AC couple using the CSW, and when the batteries get full, when the grid is down, the inverter will frequency shift, knocking the inverters offline to protect the batteries. But the best way is if you're using an inverter that also listens to that frequency shift as a signal. And for instance, our Conext SW does. We don't have an inverter for the residential market in North America that does, but as much as I hate to admit it, Sunny Boys, most models, certain models of Sunny Boys do. But what that means is if the customer has the appropriate Sunny Boy Classic, among others, installed, when the batteries get full, the inverter shifts its frequency, and the grid timer sees that as a signal not to shut off, but to curtail its output to match the loads. So that really is the smoothest way of doing things. But one thing I want to say here is that if you're planning on doing an AC coupled system, the first thing you need to do is talk to your batteryless inverter manufacturer about it. Quite frequently, it's not going to be a Schneider product that's up there. Even if it is, talk to us. But some inverter manufacturers will actually void the warranty. Some inverter manufacturers just will not stay connected. This is not a put down to them. For instance, Fronius. My understanding has always been, and I heard this from Fronius as well, that their anti-islanding routine currently will not be fooled, if you will, by a battery-based inverter. So if your customer has a Fronius inverter on, wants to do a battery backup retrofit, you're going to have to do something like potentially add one of our 600-volt charge controllers and do it on the DC side, which would negate any rewiring, or put in a different grid tie inverter. They have a Sunny Boy, very good potential that they'll be able to just frequency shift it and slow it down. If they have an inverter, well, for instance, Solar Edge, I happen to know, I've heard that it works, but I've also heard that they void their warranty. So the lesson here is that if you're planning on doing an AC coupled system, always talk to the batteryless inverter manufacturer prior to doing it. But the CSW inverter can be programmed to change its frequency to do these other routines as well. So, now, one thing I'm going to add here, when we talk about AC and DC coupling, please note that they are not mutually exclusive. Like in this system, you can use both. And there are reasons you would want to. I'm not going to go deep down the AC coupling tunnel today, but that's going to be a webinar for the future when we get into to applications. So just keep coming back for the webinars, and we'll eventually go very deep into that little subject. This one is one of my favorite features of the CSW inverter, particularly for an off-grid, but even if you have a battery backup situation. So many of us that know battery-based inverters know about the pass-through function of an inverter. When the grid or a generator is available, it passes through the inverter. We can see it going through these two relays here. These are 30 amp. So we can have 30 amps at 240 passing through the inverters out to the loads, whether that be the generator or the grid, also going down, and the excess, if the loads are lower than that 30 amps, any excess can be used to charge the batteries. Very nice feature. Start the generator up, charge the batteries, run the loads. And with generator support, for instance, we can limit and not blow the breaker on a generator. So for instance, if I had a generator capable only of 15 amps at 240, I could program the inverter to only accept 15 amps from it. So now if I had less than 15 amps of loads on that L1 and L2 output, the excess energy could be used to charge the batteries. If the loads were above that 15 amps I programmed, it would then draw as much as it was told to from the grid, as well as draw from the batteries. So you could potentially eventually drain your batteries if your generator wasn't large enough. But from a backup standpoint, quite often a customer doesn't want to have a very large generator for backup because it may not be used very frequently, so they can use a smaller generator. Very nice feature. But looking at this drawing, you would make the assumption that that would have to be a 240 volt generator, but alas, it does not. Here what we see is a 120 volt generator being used. And what we see down there, you'll see the top portion of that transformer here. This is where we're stepping down and going through our charger section to charge the batteries. But what we see here are two series windings. And the technical term for that is an autoformer. And what that means is if we follow L1, and we're going to say that L1 is at 30 amps. So we only have a 120-volt generator capable of 30 amps coming into our inverter. Now, be aware, this is only for the North American version because the rest of the world doesn't use our goofy split phase. But that 120 volt will be induced across the other winding at 120 volts, 180 degrees out of phase, giving us true split phase on the output to run our loads. Note that if I have 30 amps at 120 coming in, that means I've got 15 amps at 120 or 240 going out. Because we're not going to double the wattage, we're just going to double the voltage, therefore having the current. There's no free lunch. But the bottom line is, in a little battery backup system where a customer doesn't want to have a permanent larger generator involved, but simply wants to use their portable generator, their 120 volt, on potentially like an external transfer switch, a simple external transfer switch, a manual one potentially, they can use a 120 volt generator to charge the batteries and run the loads if the solar is not enough to keep up with those long-term outages. It also means for an off-grid application where they may not even have 240 loads, they can use that 120 volt generator they've always had around. Really nice feature. If you buy an autoformer from anyone, really, the lowest price versions of an autoformer, which again is included in the inverter here, that I have ever seen, is about $600. My previous employer sells their version of an autoformer for $2,400. I won't mention the name of that company, but their initials are SMA. So, included in the inverter is an autoformer, which gives you that split phase output. Really, really nice feature, particularly for a smaller backup or smaller off-grid system. Now, in the IEC version, the world's a little simpler. There is no L1, L2, and neutral. We just have basically line and neutral, 30 amp. And yeah, so I think I pretty much have covered that. It's 2-wire. Now, don't be confused with this. If you're a North American customer thinking that you can buy a 230 volt unit and get split phase power out of it, you would have to actually add an additional autoformer to do that. So always make sure you're buying the proper inverter. You don't want to buy a 230 volt unit here. But a North American version puts out 240, so that shouldn't be too much of a confusing issue. So, but again, excess above and beyond or below the loads of the program value of that what I call AC input is what is available for charging. Now, this whole idea of AC input support or gen support or grid support, I like to lump them all under one category called AC input support. And there's a lot of features for this. There's peak shaving, generator support, grid support, enhanced grid support. All these things are really programmable functions of the same thing. And that is the ability to share DC and AC. So an inverter that does not have AC input support, if I was to put on the output 40 amps of load from a generator with a 30 amp breaker, it would simply trip the generator breaker. On an inverter with gen support or grid support or whatever you want to call it, if I program it for 30 amps, it's only going to draw the 30 amps from the generator and then use the batteries, the energy on the DC side to support the load. Great for short term. You have a large load that comes on intermittently, and you can just borrow from the batteries, and then the inverter will put it back when the loads are lower. So for a generator, that's nice because you use a smaller generator. Be aware that doesn't mean you can add the two together. So in other words, if I've got a 4 kW inverter and a 4 kW generator, that doesn't mean I get the ability to run 8 kW of loads. The idea here is, from a generator standpoint, to be able to run a smaller generator. Now, firmware upgrades. These are all the things that have changed in the new CSW inverter. And if you have a current or an older SW inverter, you can upgrade and get these features. You can't change it to 48 volts, obviously. That's one of the new features. But there's a lot of good ones here. And so we're going to go through those, which should take us right into or 1 hour limit. And I broke it down. Don't worry, this doesn't take as long as it looks like it will. We're going to talk about some load shave, which is a function of AC support. We're talking about AC input support with some more details about that. Some of these things I've kind of covered. I get ahead of myself sometimes. AC coupling we talked about quite a bit. The 48-volt unit, there's not too much to be said about that other than it's available. Lithium-ion battery type, I like to talk more about detail about that and some additional features which are really good. Most of everything we've actually talked about other than these final two, but we'll briefly go through them and try to make sure we don't run out of time. So load shave. This is a function of AC input support. And so what load shave is the ability to shave the input based on time of day to keep primarily for peak demand charge reduction. So in other words, we don't see this too much in residential, but it may be coming, where they say if you exceed a particular value of peak load for the rest of that billing cycle, or even in some cases the rest of that year, you are billed on a higher tier because you have a higher demand on the grid potential. So inverters, battery-based inverters, can be used to do what we call peak load shaving. It's a function of AC input support, but it's done in order to draw from to minimize draw from the grid. And we are willing, at that point, we are perfectly willing to even almost abuse the batteries to do so. So that's really one of the differences on load shave versus, say, AC input support, which I'll get to. So load shaving allows the CSW to support or assist the AC source in powering loads during a defined window of time. So for instance, during a particular window of time where maybe we have your bigger loads and you want to keep the peaks down, you can program the inverter to do that. You can also set that value down to 0, and which would give you what some would call zero mode, which would basically use the grid only in the event that the PV on the DC side and the battery's capacity were insufficient to run the loads in an application where you're not allowed to sell back. So this load shave can be used for what I would call a self-consumption when set to 0. Okay, and I won't go too deep. Or you can do it over a period of time. You can do it all day or during a specific period of time. So the AC input in this case will be shaved using the energy in the batteries until the batteries reach something we call low battery cutout, which is why I say in this application we're typically willing to dive deep into the batteries and utilize that energy. But depending on the application, that can be preferable. Now AC input support is really the same thing. We're really just sharing the DC with the AC, but we're doing it for a different purpose. In this case here, we don't necessarily want to dive into the batteries because we don't want to cycle them. What our primary goal here is just to utilize the solar. So now we're basically doing this without going into the batteries. We're only shaving and contributing from the solar with, to the AC input, but we're not necessarily dipping into the batteries. As a matter of fact, in most of these applications, it's not desirable, but we leave that up to you. Now, if you're using that battery meter that I was speaking of earlier, the Conext battery monitor, you also have the ability to do all this based on the state of charge as opposed to voltage only, much more accurate. And then we have something called enhanced grid support. And this is when you use a ZAN bus enabled, or yes, one of our charge controllers, the 60 or the 80 amp controller. We can actually prioritize things even a little bit more efficiently. So normal, other inverter manufacturers do this AC input support. The way they prioritize is to, number one, prioritize the solar. Number two, go to battery. Number three, the grid, which cycles your batteries. It's a little bit more inefficient, and it does prematurely, have some impact on battery life. When we enable what we call enhanced grid support mode, we do this because we're letting the charge controller take over the game and not the inverter and the utility. We then prioritize the solar number one, which makes total sense, but we do not go to battery at all. We go, if the solar is not enough, we use the grid and we leave the batteries alone, resulting in a more efficient operation, less microcycling on your batteries, improved battery life, a better option for those systems, particularly where power outages are infrequent. So it'll give you it's a much better operation. Grid interactive delay feature, so you can actually postpone the whole load shape thing until, and AC input support until your charge controller lets the batteries get to float for 2 hours. This ensures that your batteries are full, but that energy came from the sun, not from the grid. But we let it go into float for 2 hours to ensure the batteries are full. Again, these are all programmable options. You know, we don't tell you how to do things. We just give you all the options to do them. One of the things I really like about all of our gear. AC coupling, this one we spoke about at length. I don't think we need to go into this any deeper. So unless there's questions, I think that I covered this earlier. We're getting a little bit low on time, and I want to make sure we get to the things that we need to get to. So I'm going to skip ahead a minute. Again, unless there's questions, and I can save those till the end too. So lithium-ion battery type. You'll be able to, I won't read all this to you, but you can look back at it later. A lot of it is just basic disclaimers. There are 3 ways that we deal with lithium-ion battery type. So lithium ions are much different than lead acid. One of the primary differences is that in a lead acid battery, as it becomes more full, the internal impedance goes up, slowing down the AC input current to or DC input current to the batteries, making lead acid a bit self-regulating. One of the benefits of a lithium ion is they have very low impedance for charging, which means that they will take whatever you deliver at them, which can be catastrophic because their internal impedance doesn't really climb if they become more charged. So they require, all lithium ion, I'll say this, requires a battery management system provided by that battery manufacturer. And those battery manufacturers deal with us in one of 3 fashions. And is their battery management system. The simplest, and I only know of one company that does it, but there are others, I just can't remember the names of them, but you may be familiar with High Energy Systems. What they do is they make a lead acid replacement battery. So they have said, they went around to all inverter manufacturers, and inverter manufacturers said, we can't really deal with lead acid, or lithium ion directly. You need to do it, but they made a drop-in. So basically you connect it to an inverter that is kind of optimized for lead acid. It has its own onboard battery management system. One of the things that it has is something that I call a Chernobyl switch, which means that if the battery is discharged or charged at too high of a rate, too many amps going in or out of the batteries, which can be catastrophic, they will open a relay inside there. It's like I said, I call it the Chernobyl switch. Keeps it from melting down. Now, this is not a good thing in a system, because if you disconnect the batteries from a battery-based inverter, it goes completely dead and loses its brains. So we have no ability to do anything. So this would be not a good thing. When you program the CSW for lithium-ion battery type, it gives you the ability to set a value at which we will shut the inverter off, and again, turn off the loads or charging, based on a programmable value that you set less than their Chernobyl switch value. That way, instead of opening up the contactor, disconnecting the batteries, we actually shut off the loads, which is less traumatic to the system. So that's the primary thing that we do in lithium ion. Now, the other 2 ways that battery manufacturers will have their battery management system function is by communicating directly with us and telling us what and when to do things. So in other words, they see the battery temperature going up, they tell us to slow down current. This is something that we can't do dynamically on our own because lead acid doesn't require that. So there's 2 ways they can communicate, either on our ZAN bus network, very simple plug and play, which is the preferable way, but they can also do it over Modbus, which is a more common, a commonly available communication protocol. So it's up to them. We release to battery manufacturers our ZAN bus protocols and our Modbus maps, and they can do it either way they choose. But those are the 2 ways. But again, one thing I really want to emphasize is you must talk to your battery manufacturer about this. They need to be in communication with us in one way or the other, or have their own, lead acid replacement management system. Do not think that you can buy bulk lithium-ion cells on eBay and then connect it to us and select lithium-ion battery type and not have a catastrophic failure. Again, do not do that. So that's what we mean by lithium-ion battery type, but the CSW is capable. This is all a changing industry on lithium-ion. There's going to become more and more standards. There's going to become more and more, communication between inverter manufacturers and battery manufacturers. So again, if you're wanting to use lithium-ion, just understand that we're on the bleeding edge of that one. It's and though it may not be a new technology, it is new to the inverter world. Again, this is all the things that I've already said. If you download it, you can print the stuff up or whatever. But I'm not going to read it all to you. I think I just described it all. So additional features. Here, this is our final items. We're going to end a couple minutes late. Now available in 48-volt unit. We do something we call store in the state of the inverter mode. So if you were to power down the unit in the off position, in other words, take the DC away, this is more of a mobile thing, but we do that here. If you turn off the power when it's in the off position, you turn on the power to be in the off position. If you turn off the DC, the disconnect the DC when it's in the on position, it'll come back in the off position. That's a new thing that's in the new firmware. No load voltage detection. What this is a power saving device. It's very cool. Most loads are not that particular about voltage. When I say not that particular, plus or minus 10% is acceptable in the grid world. What the inverter will do is it'll adjust its output voltage by +4 to -5% over the entire power range of the inverter. And what this does is it finds a sweet spot for tear loss. So by enabling this, you will see a potential variance in your output voltage by +4 to -5%, depending on the power output, but it will save power. So it's kind of a nice feature, while always having output voltage. Low battery cutout hysteresis. So the new thing we added was that when you program the inverter for a low battery cutout, which is a feature to protect your batteries, it won't just turn back on again when it gets to that voltage again. We build in some hysteresis now. So in other words, if I want to disconnect at 42 volts and reconnect not until I get up to 48 again, you can do that. So it sets a hysteresis value and a delay. So now we can say not only do we do it by voltage climb, we want to wait. If it goes down to low battery cutout, I want to wait for X number of hours until I turn it back on again because I don't want to abuse my battery. So it's another new feature. Here I have the spec sheet for both units. We don't really need to read that. I think I covered the specs. So really, more than anything, what I have here is my email address. So that wraps it up. I went over 4 minutes. That's not bad. Don't shoot. If you have any questions, feel free to pipe in now, come off of mute, and ask questions. If not, thank you all for coming. I'll be doing this presentation later again today. It'll be the same one, so unless you really enjoyed it, you may want to skip the afternoon session, or might be morning for you, depending on your part of the world. But again, I think the next installation is going to be the CL grid tie inverter, and then on to the grid charge controllers, I believe, and some other things. But keep posted. I don't know how it's appearing on our website. It's a fairly new thing, but all of you found this one, so I'm sure you'll find the next one. And again, unless there's questions, thank you all for your attendance and your participation. I think hopefully I covered the questions, and there were none. But thanks for all your attention. I appreciate it.